Hello everyone, let's discuss the working principle of transformer. So we all know that the working principle of transformer is Faraday's law of electromagnetic induction. Working principle of transformer. What is that? Faraday's law of electromagnetic induction. So transformer is working under the principle of electromagnetic induction. This is the main principle for the working of transformer. So the main aim of Faraday's law Faraday's law of electromagnetic induction is to induce EMF in turn current flow and power transfer is made possible, and power transfer is made possible. So the main working principle of transformer is what? Faraday's law of electromagnetic induction, and the main aim of this law is to induce EMF, which in turn produce current. Because of that current, there is a power transfer is taking place. So what is this meaning is, let us assume so this is the transformer core. For this transformer core, I have a winding, whatever may be the winding. So this is the supply voltage, and the secondary is open. Okay, let us assume the secondary is open. So we all know that we have a supply voltage. Because of the supply voltage, there is a current, right? Because of this current, there is a flux, right? Because the current direction is like this by using right hand thumb rule. What about the flux direction, which is nothing but upward direction, which is nothing but this direction, which is nothing but phi m, right? Phi m, this is flux direction. So because of the supply voltage, we have a current, then we have a flux. So because of this flux, rate of change of flux linkages, we have what? Self-induced EMF, right? So here E mutual induced EMF. Because the secondary is open circuited, there is no current, because I2, let us say 0 amperes. Let us assume this is I1. So because of this supply voltage, we have a current. Because of this current, there is a flux. Because of this flux, there is a EMF, right? self. Simultaneously we are going to get mutual EMF. That's it. So there is no load between this. Load is absent, that's why it is called as open circuited, right? This is the criteria to get self as well as mutual. When there is no load, there is no current, obviously there is no, that is V2 which is equals to 0. Only we have, let us assume E self should be equals to E1, E mutual should be equal to E2. So only we are having E1 and E2, up to E2 only we are having the quantities. Let us assume a load which is present across secondary. This is the core. For this core we have transformer winding. So this is the supply voltage. So this winding is called as primary winding. Let us assume across we have a load, right? This is load. So supply voltage, then primary current. Because of this there is a flux, right? Flux, the current direction, based on this current direction we are going to get the flux direction, and this is what I2, and finally what we are having, this is E1, this is E2, this is what V2. Clear? So what is the conclusion here? When load is absent, when load is present. So when load is absent, what are the observations? We have supply voltage. Here also we are having supply voltage. Because of the supply voltage we have current. Because of the supply voltage we have current in this case also. Because of this current there is a flux. Because of this current there is a flux. Clear? So because of this flux we have E1, because of this flux we have E1. So the transformer main principle is what? Mutual induction principle. So obviously simultaneously we are going to get E2, mutual induced EMF. Mutual induced EMF. Clear? Here the load is absent because I2 is equals to 0. When I2 is equals to 0, there is no terminal voltage across secondary. So for this the cycle completed. But coming to when load is present, we have supply voltage. Because of this supply voltage there is a current. Because of that current there is a flux development. Because of that flux there is a EMF, that is self-induced EMF. Because simultaneously we are having mutually induced EMF. What is mutually induced EMF? The rate of change of flux linkages due to excitation in the another coil. So because of this induced EMF there is a current, because load is connected. Because of this I2 we are having another flux phi 2. Because of this phi 2 we have what? V2. Because of this flux we have V2. So when load is present, when load is absent, this is the main principle of transformer. So let us consider a coil. We all know that before that what is the induced EMF which is present in transformer? Statically induced EMF, right? Statically induced EMF, right? Why it is statically induced EMF? Because transformer is static machine, there are no moving parts. So what is the magnitude, which is equals to minus n d phi by dt, which is equals to what, rate of change of flux linkages, rate of change of flux linkages. That is what is that meaning? Time varying magnetic field and steady conductor, right? Time varying magnetic field, steady conductor. So when time varying magnetic field is present along with steady conductor, obviously an EMF will be induced. That EMF is called as statically induced EMF. So what is E1? We all know that statically induced EMF is of two types, right? Which is nothing but E self, E mutual, which is nothing but E1, which is nothing but E2, right? So to get better clarification, let us having a coupled circuit. So for this we have windings. So these are the windings and this is the supply voltage, okay? And like that we have winding on another side. In this side we are going to connect a load, right? This is load, this is supply. So we all know that we have V1, so obviously there is a current I1. So because of this current, obviously flux will be, by using right hand thumb rule, this is the flux direction, right? Let us assume this is coil A, this is coil B, okay? So these are the number of turns N1, number of turns N1, number of turns N2. So what about the EMF which is induced, which is nothing but E self, here E mutual, this is what, V2. Because of this there is a current I2, right? Because of the mutual induction principle, because of this flux, because of this load, there is a current in this. This is I2, this is V2. Clear? So what is self induction property and mutual induction property? Self induction property. What is self-induction property? When current in a coil changes, what will happen? The flux linkage of same coil also changes. Also changes. This property is called self-induction property. Then what about mutual induction property? What is mutual induction property? When a current in a coil changes, a current in a coil A changes, what will happen? Flux linkage in coil B changes. Because of this excitation in coil A, there is a flux linkage in coil B. This is called mutual induction property. So what is self-induction property? We all know that E self, which is equals to minus N d phi by dt, right? So which is equals to minus N, or let us say N1 primary terms, d phi by di into di by dt. So let us say E self, which is equals to minus L self di by dt. This is about self-induced EMF. This is about self-induced EMF. Coming to mutual induced EMF, minus N, now it is N2 d phi by dt, which is equals to minus N2 d phi by di into di by dt. Now we can say that minus M di by dt. So E mutual, which is equals to minus M di by dt, right? So we have conclude. Now we have to conclude one important point. Transformer is a coupled circuit. What are those important notes? Transformer is a coupled circuit. So if a load is connected across, what is mean by coupled circuit? If a load is connected across coil B, what will happen? Current will flow through the load. Current will flow through the load and power is supplied to the load, and power is supplied to the load. So this power transfer is due to what? Mutual induction property. So this power transfer is due to mutual induction property. So in transformer, power transfer between the windings is due to mutual induction property. That is the principle. In transformer, power transfer is due to, or you can say in transformer the power transfer between two windings is due to mutual induction property. This is the main working principle of transformer. So transformer is working under the principle of mutual induction. So what is the working principle of transformer? Which is nothing but Faraday's law of electromagnetic induction, that to mutual induction property. So this is the total summary of this explanation. Thank you.